Hi, my name is Guy Notham, and I am a product specialist at ACIST Medical Systems. I want to introduce to you Rapid FFR. Rapid FFR is done using the Rxi and Navvus MicroCatheter. The Rxi and Navvus MicroCatheter utilizes a fiber optic transducer for measuring an accurate FFR. The Navvus MicroCatheter is a monorail catheter that allows the interventional cardiologist to use their interventional wire of choice and maintain wire position within the coronary artery throughout the procedure. The Navvus MicroCatheter has an entry profile of just 0.16 inches, and the tapered tip allows for smooth transition through any coronary disease. The fiber optic transducer is positioned just 5 millimeters from the tip of the catheter, which is our competitive advantage. Pressure wires have a transducer set back 30 millimeters back from the tip, which requires much more real estate to get their transducer beyond a coronary stenosis. The Navvus has a 26 centimeter monorail segment, which is similar to most angioplasty balloon systems. The Navvus has two femoral markers, one at 80 and one at 100 centimeters. The working length of the catheter is 150 centimeters, and the total length is 335 centimeters, which gives flexibility to the placement of the Rxi system anywhere on the cath lab table. The Rxi Console is a simple plug and play when it's mounted bedside with the patient's aortic pressure running through it. Simply plug in the catheter, wait for the light to turn from blue to green, and the Navvus sensor is ready to be placed in the body and equalized. Before I get ahead of myself, let's take a look at the Rxi Console itself. The Rxi Console has three cables on it. The power cable, which supplies the unit with power. The second cable brings the patient's aortic pressure into the console for FFR calculation. So then we can see the pressure waveforms of the patient on the system. The third cable is actually for exporting the Navvus catheter pressure into the cath lab hemodynamic system. This becomes important when the cath lab Hemosystem has the FFR software. Across the top of our system is the status bar, and it tells us exactly what step needs to be done next to move on into the FFR procedure. The PA value, this is the mean arterial pressure of the patient. The PD is the mean distal coronary pressure. The PD-PA ratio, often referred to as the resting gradient, is best utilized when equalizing pressures. When equalizing, the PD-PA ratio should be 1, meaning there's a 1-to-1 relationship between the pressures. When recording, the Rxi Console will track the pressure gradients, calculate the FFR, and display the value here under FFR. Working around the screen, the record key, or the record button, records the hyperemic response, then is the zero aortic button. Now the zero aortic button is only used at the time of install. Then we pair or match this system with the hemodynamic system, so you no longer have to zero the system unless you choose to. The next button is the equalize button, followed by the PV button. Now PV allows the user to input a central venous pressure into the FFR calculation. For an accurate FFR, it's important to remove the resistance to blood flow. A high venous pressure increases resistance to blood flow, therefore a PV value should be used in the calculation of FFR. The Rxi is the only FFR system in which the PV value can be easily input. On the bottom of the screen is where we see the FFR values. 10 FFR values can be done per vessel, and 10 vessels can be done for a total of 100 FFRs per patient. The case summary is where all the FFRs can be reviewed. In addition, each FFR vessel can be labeled with the appropriate name, either by picking a name from a bank of names, or the user can free text the name using a keyboard. The first thing we need to do when we bring the Rxi system into a cath lab is zero this system to match or pair it with the hemodynamic system. So what we have to do is just simply hit the 0 aortic button. However, we have to ensure that the hemodynamic system is reading a 0 pressure at that time. Our RXi system is now connected via our cables to the hemodynamic system. The first step we need to do is 0 the RXi system to the Hemosystem, but we have to ensure that the channel 1, which carries the patient's aortic pressure, that this channel is at 0. If it says 0, this channel is not activated and will not provide us an accurate 0. What we need to do is ask the tech to 0 the system first. So we have to ensure that this channel is getting a 0 signal. We want to 0 it to an open transducer. And now that the channel is reading zeros all the way across, this is the only time that we can 0 the RXi system. By pressing 0, we've simply told this system whatever signal it's coming in, hopefully it's a 0, that is a 0. So now it has moved whatever signal it was reading to that 0 line. Now that we've 0'd the system, the first prompt in the status bar will read Connect Pressure Sensor. PA scaling is used when we input a known pressure into the hemodynamic system. In this case, 100 millimeters of mercury pressure is input into the hemodynamic system, but the RXi is reading 102. We can adjust the PA measurement by going under the drop-down menu to Waveform Settings and PA Scaling. Now, by adjusting the PA scaling down, we can set this to 100 millimeters of mercury pressure, and hitting OK calibrates the Rxi Console. When a physician asks us to open a Navis catheter for the procedure, the first thing we want to do is have the monitoring tech bring up the channel in which we have the Navis plugged into. In this case, it is channel 2. Because the RXi system sends a 0 when there's no catheter plugged in, we can immediately have the monitoring tech 0 that channel. Now we're ready to have the patient's aortic pressure and the Navis catheter displayed on the cath lab hemodynamic system. Now we're ready to connect the catheter into the RXi system. So what we're going to do is open a catheter, place it on the table, and we're going to immediately plug in the purple hand controller into the RXi system. We're going to wait for the light to turn from blue to green. At this time, we can go ahead and flush the hoop with saline and then remove the catheter from the hoop and introduce it into the body. Now we have the Navis catheter sensor in the body positioned at the guide catheter tip. And you can see both pressure waveforms are displayed on the screen. The red is the patient's aortic pressure. The green is the Navis catheter pressure as measured by the fiber optic transducer. You notice at the top of the screen it says ready to equalize. By pressing equalize, we're telling the system whatever that aortic pressure is, we want the Navis catheter pressure to be exactly the same. And that will superimpose those two pressures on the screen. Now, with the physician's wire of choice in the body, we can simply advance that transducer inside the coronary artery to the area of interest, and we're ready to start adenosine. Once the patient gets that hyperemic response of the adenosine, we can simply hit record on the screen and we'll record that hyperemic response. You can see how the PD-PA ratio was tracking the FFR the entire time. And when the FFR got to be the lowest, the system seeked out that value and placed that here under FFR. We're going to stop the recording, And now we have to make a choice. Do we discard that information or do we save that information? The white dotted vertical line shows you where the RXi sees the lowest FFR value and places it here. Well, let's go ahead and save that value. We'll go back to the live picture, and now that value is held here under our first FFR. Now we can go ahead and choose, if you want to do another recording. And we can stop that recording at any time. Now if we save that recording, that value will be placed in the second slot here in the FFR. Now it's always good to label what we want to call the vessel that we're in. Here we have a drop-down menu in which we can pick from. So if we were in a distal LED, we'll simply select that. Distal LED will be displayed here with our 2 FFR values. In the case you have an additional vessel that you would like to do an FFR in, we can go ahead and hit New Vessel. New Vessel will take us to Vessel 2, which is the default. We can go ahead and hit Vessel 2 and select the vessel that we're in this case an OM. Because we have a microcatheter on a wire of choice, we can easily go into the next vessel, get our fiber optic sensor positioned in the correct area, and we can go ahead and start adenosine once again. Then, once we're at peak and maximum hyperemia, we can record that FFR in that vessel. We can stop this recording at any time. We can save that FFR, and now we have an OM with an FFR of 0.70. Now at any time we can go to case summary, and here is displayed the LED and the OM FFR. On the RXi we have a drop-down menu under the ACIST label in the upper left-hand corner, and we can go ahead and access all the submenus here. Now at the time we can go ahead and go under System Settings, and we can change the language and the date and the time. Here's where we enter the facility name, which can be done at the time of install, and that does not go away unless you go in and change it. Under Lab ID, this is where we have the ability to select whether we're going to be moving the RXi system from room to room or if it'll be stationary in one room all the time. Now you heard me say that we only have to zero this system to the hemodynamic system one time, but that is when it is in the stationary mode. Then we're essentially telling the computer that it's going to be staying in one room, it's matched or paired to that hemodynamic system, and that hemodynamic system won't change. So then we can go ahead and program the software essentially to skip the zeroing step. If it is in the mobile mode, now we're telling the system that this will go from room to room, and it'll program the software to prompt the user to zero this system for every FFR procedure. Audio volume, also touch screen calibration if the touch screen calibration becomes uncalibrated. And then finally, we have a submenu down here for installing software for making the system upgradable. Underneath pressure waveform settings, we are able to change how the pressure waveforms look on our screen. We can set the mean pressure calculation to 1 or 3 or 4 or 8 or 12 beats. So essentially what that is that this system will calculate a mean arterial pressure after the third beat. It defaults to 3. If the user is using IV adenosine and wants to go to 8 or 12 beat mean, they can do that. We also have sweep speed. That just really shows how fast those pressure waveforms go across the screen. Then it's followed by the graph scale maximum, and that's what the scale is on this system from 0 to 100 or 0 to 200. And then finally, we can restore all the defaults to how those pressure waveforms look on the screen by hitting Restore Default. Under our main drop-down menu, we also have Patient ID. So if you choose to, you can put a patient identifier, either an MR number or the patient's name or perhaps their initials in here, which will be tracked with that FFR. Zero pressure sensor, we have that capability, but if we're going to hit this, we have to make sure that that pressure sensor is outside of the body when we recalibrate it. You notice when we plugged in our purple connector into the front of the unit that it's self-calibrated. There should really be no reason to do other zeroing of the pressure sensor, but if the physician chooses to, he would do that right here. So this concludes my in-service. I hope you found it helpful, and happy selling.